Today we're going to talk about relative extrema. This is also another word for this is local extrema. So, what is a relative extrema? Well, given a function such as this, relative extrema is any point on the function where the function is going from increasing to decreasing or from decreasing to increasing. So the points at where that transition happens are called the relative extrema. So this point over here would be 1, and this point over here would be 1, because it's going from increasing on this side to decreasing, and decreasing on this side to increasing. So these are the extrema. When the function is going from increasing to decreasing, and that extrema point there is called a relative maxima. And when it is going from decreasing to increasing, that extrema point there is called a relative minima. So how do we actually find these points? Well, we know that the derivative of fx, so say this function is fx, we know the derivative of fx, f prime of x, is equal to the slope of the tangent line. So if we find the slope of the tangent lines at these points, so this line and this line, if we find the slope of these, we can set fx equal to that and solve for it. Well, we know the slope is 0 because on this side of the function, we have a negative. When the function is going from increasing to decreasing, we have the tangent lines at a positive slope going to a negative slope. And when the function is going from decreasing to increasing, we have the tangent lines going from a negative slope to a positive slope. Now, any time that you're going from negative to positive on this number line, 0 is contained in the middle, and 0 is the point where the negative to positive, the transition actually happens. So the slope of these lines is 0. So we set f prime of x, equal to 0. And we solve. So say we get two numbers, x equals a and b. So we can get any amount of numbers, any amount of critical points, depending on how many extrema there are. And these points are called the critical points. Critical points. But we want to know whether these critical points are given at a maximum or a minimum. So we do something called the second derivative test. F double prime of x. We take the second derivative of fx. Now when fx is going from increasing to decreasing, when there's a maxima, f double prime of x will be less than 0. And when fx is going from decreasing to increasing, f double prime of x will be greater than 0. And when there is when the function, there is a possibility that the function just keeps increasing or keeps decreasing. So if that is the case, and there's no extrema there, f double prime of x equals 0. So to find whether the critical points are given for a maximum or a minimum, we plug in. So we find if x is a and b, to find whether a and b are given at a maximum or minimum, we just plug them into f double prime. So f double prime of a, if f double prime of a is less than 0, then the x-coordinate of a is given at a maximum. And if f prime of b is greater than 0, then the x-coordinate of b is given at a minimum. So to find the actual coordinates, now that we have determined whether a and b are given at maximums or minimum, we just plug them into f of x. So if we have a, and then we have f of a, which is the y-coordinate, this is the point at where the maximum is. So this is the relative maximum for this function. And if we have b and then f of b, this is the point at where the minimum is, the relative minimum. So that is how we find relative maxima and minima, or relative extrema. So if we take a function f(x) equals x cubed minus 3x squared plus 6, and we want to find the relative extrema, we would first take the derivative of fx, which is f prime of x, and this is equal to 3x squared minus 6x. Since this is a constant, it's just plus 0, so it doesn't matter. And we know that the derivative of fx is the slope of the tangent line at a point on fx. And we know that the slope of the tangent line at the extrema is equal to 0. So we can set this equal to 0, f prime of x. So then we can factor x out of this to get x times 3x minus 6 is equal to 0. We get x is 0 and 2 from this. We have found the critical points, but we want to know whether 0 is at a minimum or a maximum, and the same for 2. So we can use a second derivative test. So we take f double prime of x, and this equals 6x minus 6, and we evaluate for 0 and 2. So f double prime of 0 is equal to 6 times 0 minus 6, which is simply equal to negative 6, and f double prime of 2 is equal to 6 times 2 minus 6, which is equal to 6. Since negative 6 is less than 0, we know that for x equals 0, there is a maximum. And since 6 is greater than 0, we know that for x equals 2, there's a minimum. So now we just we evaluate fx for 0 and 2 to find the y-coordinate. So f0 is equal to 0 cubed minus 3 times 0 squared plus 6, which is equal to 6. And f of 2 is equal to 2 cubed minus 3 times 2 squared plus 6, which is equal to 8 minus 12 plus 6, which is equal to 2. So now we have found the coordinates. So at 0, 6, there is a relative maximum. And at 2, 2, there is a relative minimum. So that is how you find the relative extrema of a function.